Okay, guys, this is Rhinoceros3D software, CAD software on the right-hand side. We have a parametric modeling tool. This is Grasshopper3D, and it's embedded inside Rhino, so you don't need to install and extract software. You can simply type Grasshopper and enter. And this one will be opened, and you can start using blocks to have special, let's say, geometries. So what I've done a moment ago is that we have drawn a box shape here, and now I will take it as an input. So what I do is a B-wrap shape, so I will have a B-wrap geometry. Now I will right click, set one B-wrap, and I will use this one. Okay, now this is selected. So what I'm going to do in this small demonstration is that I will take slices and show you the contours of this simple box. So what we need to have, in order to take the slices, we need to have a plane, and that plane will be on X, Y. So let's have a kind of an XY plane. Yes, here it is. But the thing is that initially this has an origin at 0, 0, 0, but we will actually move this plane in the z-axis, and that will help us obtain slices at different levels. So if you simply take the intersection, then you will only have, let's try to do it. Now we are going to intersect this plane with our designed part. This is B-wrap. So I will now look for a component intersection. This part is for intersecting the components. What are we going to intersect? We will intersect B-wrap and a plane, right? Okay, this is plane. Now I'm connecting this input to the output of the plane. Okay, and this is B-wrap input. Now this is connected. But let's first now I will hide this shape and also hide this plane, or let's keep it, doesn't matter. Now this was the original box actually we have drawn on the Rhino side. Now I will hide it by clicking this. Now you see we don't have the object, but we have the slice here. This is the slice we obtained, and this is obtained at z is equal to 0 value. But how we are going to change it? How we are going to change this z value? Let me move this one here. We may create a point instead of having the default point here, O, which is origin. Right now it's 0, 0, 0, but instead I may have such a point here. Let's call the component construct point. Yes. And for the point, we need to have some obvious x, y, and z values. For x and y, we can have 0 value. It doesn't matter. For us, the most important component is obviously the z value. Right now, I will connect it to the xy plane. As you see, nothing has changed. Why is that? Since right now, the coordinates of the point is the same with the previous coordinates. What I'm going to do is to have a variable for the z components. Let's have a kind of a slider, number slider. And by double clicking this one, we can set the minimum and maximum values. What is the height of our object? I think around, let's say 20. Let's make it 20. And I don't want to see 3 digits. Let's make it 1. Okay. Now, by simply moving this slider, we can change the value, change the output of this slider. And now I'm simply going to connect this one to the z coordinate. And you will see that right now we have an error. What do you think is that? It says that intersection failed. There is no intersection. Since our z value is right now at 16.1, probably it's not intersecting. Yes. Now you see the error is disappeared. essentially an intersection. And I think the height of our object is around, I think, 12. So make it, let's make it 12. Okay. Now we are not going to have any errors. On the side of this box, let's draw another shape, sphere. Now I will move it. Okay. Now I will change this input. I will simply click set multiple B wraps. This time I will have, I'm sorry, let's make it visible. Set multiple B wraps, the sphere in the box, enter. Now let's again hide these. So, okay. Now I'm again changing the layers. You see, you can easily have all these layers. Now slicing is done actually, but if you want to see all the slices at the same time, then you may use a kind of a range box. That will be somewhere here. It will be kind of a sequence, or I'm sorry, it should be a set or sequence. Yes, a range. Create a range of numbers. Okay. Let's have a look at the inputs. Domain of locally defined value is right now between 0 to 1. Now let's right click and set domain. Let's make it, I think, was it 16? I think it was 16. Commit changes, yes. No, it was 12. So let's change the domain to 0 to 12. Okay. And the other input is the number of steps. How many numbers are we going to have in this range? It's right now 10, but let's make it 10 times 12, 120. Okay. Okay, now if you look at the output, it's starting from 0, going by 0.1 differences up to 12. Now I will use it as an input to my plane. Now, and another thing, I should make it invisible. So this one is not working, obviously. And here you can see the slices, but since we have many of them, it's quite difficult to see. So let's change this number to 20. See, now we have 20 slices. These slices are obtained. Why it didn't work with the sphere? So that's selected again. Oops. Let's make it visible. Now I will change this B-wrap to this one. Yes. You see, we have slices starting from 0 to 12, and since this one is a bit larger, we don't have the rest, but I can simply set it to, say, 15. Yes, now you see that we have slices of this sphere. Or let's draw another example, a pyramid. Now I will set B-wrap once again. Okay. D is not enough. Let's make it 20. Changes. Yes, we have this pyramid divided into slices. And this actually is 30% of your third mini project. You can easily do it. There are different ways, and this is how I did it, but you don't need to use the same approach. And you can see an error. This is due to the intersection issue, since for the upcoming, for higher planes, we don't have an intersection of this pyramid with these planes. That's why it gives an error, but it's not important. And on the other hand, you can also use meshes. And for mesh, once you use meshes like STL files, the thing is that you need to have a different intersection, let's say, component. Here we are using BREP and plane intersection, but for the meshes, obviously, we need to use mesh and plane intersection component. And so in the project, you are going to actually embed, let's say, the slices of the spheres onto these surfaces. And if it's a box shape, the things are straightforward, but your implementation should work with any kind of object, having different surfaces, form surfaces. That is the main challenge actually. But for the simple shapes, things are not that complicated. Any questions, guys, do you have?
Yep. Can I ask, can you show any example input, user inputs, like minimum, like as a demonstration?
Yeah, these are the inputs for the CAD model.
Like mesh STL file or?
Yes, we can use it.
And worse.
Let's have another input, text input. So the user, I think, what was it? Panel, I forgot. Yes. You may use panel as a text input. So the user may write, let's say, their names, and then you may have another kind of box here. It will convert it to a Braille representation. For the Braille conversion, you may use available tools. You're allowed to do that, but for the rest, we cannot do it. And this is the second input. The third input is the surface. You can have it anywhere you like. You may have a kind of another name. Okay, I think we may have a plane. That might be the input. So set one plane. So the user may set the plane here. Let's switch to 4 quadrants. For instance, if the user wants to have it in front, so it will just use this part. Okay, and then you may even orient it. But if you have it again in the front, yes, now we have just a front plane. Okay, so these are the typical inputs. So I can say that this mesh is one of the inputs, or BREP might be the CAD input, and then your text input, and finally the plane input. As I mentioned at the beginning, if your plane is oriented, if the plane depends on the shape, not just simple planes like top, bottom, right, front, back, but if it's the plane of the object, then you will get 20% bonus. Any other questions, guys?